Okay, logarithms basics form. Two x is equals to 4, and we used to do 2x is equal to 2 raised to power 2, therefore x is equals to 2. This was index form, simple index method. But what if we have a number like this, which does not have any product of 2 or base of 2? Now we can do it by logarithms and converting it into logarithmic form, applying log on both sides. Log of 2 raised to power x is equals to log of 3. Now applying power law, we can bring this x outside. So x log of 2 is equals to log of 3. When we divide this on both sides, you can write this, and you can also punch the same in the calculator, and this, because we had same base. When nothing is written, it is understood that base is 10. And generally we can convert logarithmic to index and index to logarithmic form. Suppose we have x raised to power p is equals to q. So this would be p is equals to log of q to base x. And if we have a logarithmic form already, let's say y is equals to log of x to base of g. So index form reverse of this would be g raised to the power is equals to x. Now there is a slight condition about the form. For example, if we generally write log of a to base b, so we know that a is greater than 0, we know that b is greater than 0, and we know that b is not equal to 1. That means both of these values are always positive, and the value in the base cannot be 1. Why so? Because log of 1 is actually equal to 0, and we just practiced that log 3 by log 2 which came into the base. We can also write this as log of a and log of b split. So if we take log of 1 in denominator, that would be 0, and it cannot be the case, which would be undefined. So quick examples. If I write log of 3x to base 5 is equals to a, so I can convert it as 3x is equals to 5 raised to power a, and x would be equal to 5 raised to power a over 3. Now we have few examples which we can do to find the value without using a calculator. For example, questions are log of 64 to base 4. So we can write log of 4 cube to base 4 using power law. We can bring this power outside, which is 3 log 4 to base 4. Power law is log of x raised to power y. This y can actually come out, so y log of x base z. And when we have power in base, for example log of x, and this is z, and we have power of base, this also comes out but as a reciprocal. So this would be 1 over y log of x to base z. So if we have a number log of 4 to base 16, if this is the question, I can write log of 4, this is 4 square. Now when you bring this 2 out, this comes out as a reciprocal. So 1 by 2 log of 4 to base 4, is 1 by 2, as we know that log of x to base x is equal to 1. Short forms for few basic terms could be like log. When we know that base is 10, we can write lgx. Log, when we know the base is e, we can write ln. So ln is understood that base is e for the log. Now if we have the question that lg1, this is same as log 1, which is basically equal to 0. And if we just expand it like log 1, base is understood that it is 10, and when we take it on the other side, that is 10 raised to power 0, basically makes it 1. So log 1 is 0. Evaluate few questions before we jump on to main properties. Log of 10,000 and log of 3 to base 81 and log of 1 to base 9. So let's start with the first one. This is log of, let me say this is 10 raised to the power 4. Now it is understood that base is 10. When I bring this 4 outside using power law, I'm actually left with LG10. And we know that LG10 is 1. How do we know that? Because LG10 could be written as log of 10 to base 10, which is equal to 1. So this is 4. On the other side, we know this is log 3, and 81 could be written as 3 raised to the power 4. When we bring this 4 out, this comes out as a reciprocal and left with log 3 to base 3. Answer is 1 by 4. Now this is log 1 divided by anything. Log 1 is 0. 0 divided by anything is 0. Laws of logarithms. When we have a product, log of AB could be expanded as log of A plus log of B. And when it is written that log of A divided by B, it could be written as log of A minus log of B. Whatever is in the denominator comes with a negative sign. And third is log of A raised to power K could be written as K log of A, known as power law. So quick practice example, like if we write log of A square B cube over C7, so we can split them as log A square plus log B cube minus log C7, and next step would be 2 log A plus 3 log B minus 7 log C, and reverse of this is also possible. Like if we are given with different numbers and we are asked to write them as a single log, for example log of 5 minus log of 4 plus log of 3, so we write them as single log. With the numbers which are positive, we multiply them, and the number with which negative sign is written, we divide them. So this would be log of 15 by 4. So let's do a practice question applying the rules of log. For example, we have a question: log of x to base 3 minus 4 divided by log of x to base 3 plus 3. When we have to solve for x, what we can do is, I'm going to use substitution method. I'm going to write log x to base 3 as y. So y minus 4 over y plus 3 is equals to 0. The next step is I'm going to either take the LCM or multiply with y on both sides. So this will be y square minus 4 plus 3y is equals to 0. Rearranging before I get to midterm breaking, I'm going to get midterm breaking. This is y square minus 4, and I know that 1 4 times is 3. So plus 4y minus y. Adding both of these, I'm getting 3 and multiply. Okay, done. So y, this is y plus 4 minus 1, y plus 4 is equals to 0. Now we get two of the factors, y minus 1 into y plus 4 is equals to 0. First factor, y is equal to 1. Second factor, y is equals to minus 4. And we knew that y was equal to log of x to base 3. Now we can substitute log of x to base 3 is equals to 1 on the other side. Log of x to base 3 is equals to minus 4. We solve for x, we change it into index form. This is 3 raised to power 1, x is equals to 3. On the other side, x is equal to 3 raised to power minus 4, could be written as 3 raised to power 4, and x is equals to 1 over 81. Any confusion till now? If we have a question which says log of x plus 1 minus log of x square minus 1, and the question says to simplify. So we can write them as single log. Because of this negative sign, we are dividing them. Now further, I know that numerator stays as it is and denominator is basically a square minus b square. X square minus 1 is actually x square minus 1 square. So a square minus b square could be written as x plus 1 into x minus 1, and we can get rid of this. So finally it is simplified to log of 1 divided by x minus 1. And there's one more thing which we can do is bring this into numerator, and that would be minus 1. Power changes. Now power log, bringing this minus 1 outside, log of x minus 1. If the question says write as single log, write a single log, and the question is 1 by 2 log of 9 plus 1. So what I can do is, I'm doing a reverse of power law. I'm writing log of 9 power 1 by 2, and on the other side this is 1, and we know that log of a to base a is 1 when both are same. So I'm writing log of 10 to base 10. Why am I writing this? Because I know on this side I also have base 10, so I can convert them into single log. So this is log of 9 raised to power 1 by 2 is basically 3 plus log of 10, and when we convert them into single log we have plus sign between them, so we write 3 into 10, which is log of 30. So this right here could be written as log of 30. They have the same numerical value.